So now that we have our basic breakdown of how to form a BGP peering, both via IBGP and EBGP. Now one thing I didn't show you with IBGP is doing a directly connected connection, but normally you're not going to do it that way. Now if you do decide to do it through a directly connected neighbor, you don't have to change the update source. You would simply, from our configuration here, you would simply, let me grab this real quick, and go from 5 to 4. You could just do, on 5, you could type in neighbor of 172.16.45.4 remote AS of 12345, and the same thing on 4. You would just go to global config and router BGP 12345, neighbor of 172.16.45.5 remote AS of 12345, and then if you don't have to change anything, it's just like EBGP, but it's just IBGP syntax. You're not changing the autonomous system number. So that's generally how easy it is. That's just IBGP directly connected. The drawback to that, though, is if this link goes down, your BGP peering goes down. So if I was to go to 5 and go to interface fast 1/1 and type in shut, we go to 4, we're going to drop OSPF, or then we're going to drop BGP, and we're not going to be able to go anywhere. Now, because of the fact that these are directly connected and not through a switch, we should notice the connectivity go down. And this is why it's a bad idea to do a directly connected IBGP peering. That's why I showed you how to do the loopback to loopback peering, because then it would make everything work out that much better. So on 5, everything's gone down. Now we're just waiting for IGP on router 4 to recognize that, which it should momentarily. So there goes our OSPF adjacency goes down, and it actually waited 40 seconds because it's going to wait four full hello timers, and then you might ask, well, why isn't BGP going down? Well, BGP is going to wait 3 minutes, so it's got a 60-second keep alive timer, and then a 3-minute timeout. So if we were to go over to router 5 and do a show Ip Bgp Summary, we're still up, but if you notice right here, we're down a minute. We're continuing to we're still down, and we're at a minute. As soon as it hits the 3-minute mark, it'll stay. It'll go down for good, and then it'll show up because it'll say update keep alive. I'm gonna pause the video until that pops up just so you guys can see how that would work. Okay, and now we officially have our BGP peering is down now because we waited the 3 minutes. We go to router 5, we hit the up arrow, and now it's idle because it hit our 3-minute timeout, which can be changed. You don't have to; those will be changed, and I can show you how to do that. But I wanted to show you how that would work if it was to go down. This is why we don't do directly connected IBGP peerings. We do it to the loopback. Now, if the loopback goes down, then you're done too. The loopback has to be up. So that's how that would work. Now, from a transport establishment, EBGP packets have a TTL of 1, which means that the neighbors have to be directly connected in a normal configuration, which is how I set it up. Now, that doesn't technically mean it has to be that way, because you can set up multi-hop peers with using the EBGP multi-hop configuration. And if you do decide to do that, it's either one of two things you have to do. You either use the neighbor EBGP multi-hop TTL, how many hops, and then you specify that information, and then you'd have to do the same thing on the remote side, so they know how to look at how many what the TTL value is to look at. And then if you just type in EBGP TTL, what's going to end up happening is the TTL value will be 255, just like IBGP would. The Ttl Security, on the other hand, does it the opposite way. So what you do with EBGP multi-hop, you specify how many hops away the neighbor is. So if it's going to be 3 hops, you specify 3 hops, and that's how far away it can be. And then you would you can type in EBGP multi-hop, and however many by default it goes 255, which gives you whatever the actual hop count is. Subtract that from 255, and that's going to give you your variation of how far it could actually be away. Because it might actually be It could potentially be farther away depending on where you are in the world and if routers are added in between there. But typically, I like to say 255. It just makes it simpler. TTL Security looks at it from the other way. It's not from you to them, it's them to you. So the idea with TTL Security is, how do you prevent a scope attack from TTL? So it is possible using TCP sliding windows to figure out what the sequence number is in your TTL and your TCP windowing, and actually reset the neighbor relationship. The idea behind that is to bring down the BGP relationship. But if you are using TTL security, you're saying in the TTL configuration, you're telling it how many hops away the router is when it gets to you. So you're looking at, okay, if the router is, say, 6 hops away, then that means that when you receive your TTL update, or TTL from them, and an update, that they should be no farther than 6 hops away. If you get a router that's 200 hops away, then you know it's not the right neighbor, and that's how you're able to prevent that. So EBGP multi-hop is from you to the guy you're trying to peer with that's not directly connected via EBGP. Now, TTL security is the opposite way. It's from them to you. So that's the idea behind how that works, and that's TTL security is used to prevent attacks. Now, again, you can use multi-hop if you'd like. But you can actually disable this lookup with disable connected check, which if EBGP multi-hop is a TTL of 1, disable connected check is needed to perform the peering. If you have that set up, and I've only dealt with this a couple times, and I believe if you're not going to be, if the neighbor is directly connected, the idea behind it is you want to peer via loopbacks via EBGP. You would use this disable connected check, and you'd have to make sure that you have a route to the loopback. So you'd have to either have a static route or a tunnel or some sort of configuration in place to tell BGP speaker on your side and BGP speaker on the remote side that in order to get to their loopbacks, this is how you get there. So there's going to be some sort of, because remember, the next hop significance is huge in BGP, and we're going to talk about that here in a minute. With IBGP loop prevention, you have via the router ID. So the idea behind it is pretty straightforward. So loop prevention via route filtering. IBGP learned routes cannot be advertised to another IBGP neighbor. This is going to be a major hurdle for you if you don't understand this. And I've walked into just a couple of environments in the past where they've had BGP working, enabled on the edge, and they can't understand why routes aren't being propagated. And I smile and kindly inform them of this loop prevention technique and how to get around it, which is typically going to be redistribute the static route, or you can create a prefix list. And normally, and actually on every one of the situations I've walked into this problem with, it's always been a default route being advertised from the provider to them, and then they redistribute that into IGP, and that's how they get the route to propagate. And I just say, well, why don't you just do a prefix list, match the default route, and just do a redistribute BGP, and then match just the default route. Oh, you can do that? Yes, you can. And there's several different ways to accomplishing the same goal. I mean, that's the one thing nice about Cisco is there's usually more than one way to do what you want to do. The other thing too is with this is scaling becomes kind of a pain in the butt. So either you have a full mesh of IBGP peering, which means that every router has a connection to every other router except for itself, and that gets complicated. And so if you have 30 or 40 routers, that could be several hundred peerings, and nobody wants to deal with that. So in order to fix this issue, we get into route reflectors. And what a route reflector does is it literally does what it says. Its name is implicitly describes its operation. It reflects routes down. So as an EBGP router receives a route via EBGP, what it does is it reflects those routes down to IBGP neighbors. So what you would do on the route reflector itself, so this is going to be the guy running both EBGP and IBGP, you would simply type in route reflector client on the neighbor statement, and then all you'd have to do with all of your routers that are going to be peering to the route reflector is peer to the route reflector, not to anybody else. Because what's going to end up happening is any routes that the guy that's going to become the route reflector, or the route reflector client, Any routes that he learns, he's going to advertise them up to the route reflector. The route reflector will then reflect them back down to the other IBGP neighbors. The same thing with externally learned routes. Anything that's externally learned will be hit the route reflector and then be advertised down to the route reflector client. Route reflector client is done on the route reflector itself, so you signify that that particular neighbor and that neighbor statement is going to be a client of the route reflector. All you do on the route reflector client, which doesn't have the route reflector client configuration syntax, is you simply peer with the route reflector. So the idea is very, very simple. And I will break this down a little more in detail to it. And then the last one we have is confederations, which if you have a very, very, very large IBGP domain, which means you have hundreds of routers and a very big BGP autonomous system, and you want to simplify the administration or split it up into different areas, confederations are the way that you do this. Because then what you take is a big autonomous system and you break it up into smaller sub-autonomous systems, which is kind of sort of similar to private VLANs, where you have one primary VLAN and then you have a bunch of sub-VLANs. And we'll talk about that when we get into CCNP switch, but at the same point in time, they're kind of sort of the same. So we'll talk about how this works as we go along. And then we get into EBGP loop prevention and via the AS path. So your local autonomous system number is prepended to outbound updates. Prepended means put in at the beginning. Sorry, at the end, I should say. And the idea, append is at the end, prepend is at the beginning. The idea behind this is if you learn a route, or if you advertise a route out, you're going to put your autonomous system number in that path. You send that route out, it goes through the internet, comes back in, and if you see your own autonomous system number in the AS path, that means you originated it. So you're going to drop the update because you don't want to learn in something you advertised out because you already know how to get to it. So we have that capability there. Now the problem with this being though, and this comes into play with a couple different things. When you're dealing with summarization, or in BGP it's called the aggregate address. When you're dealing with the aggregate address, when you do this, what ends up happening is any AS path information that is learned from the beyond the point where it's aggregated, all that information, all the AS paths that it's got to go through and all that stuff is hidden. So in order to get that stuff to be unhidden, you'd use the AS set command, which is going to unhide all of the information. And I will talk about that more when we actually get into aggregation or summarization. Now, if you have two different sites running the same BGP autonomous system, so for instance, in this case, if we were running down on our down here, let's say BGP 11 and 12, and actually I might tweak these just to show you how that would look. If 11 sent an update to let's say router 1, which is BGP 1, we'll say, what would end up happening is if he sends an update down to here, and he's also BGP 11, he won't receive the update because the AS path is the same. To override this rule, you need to use the AS override, or sorry, allow AS in. This actually disables that path selection or the loop prevention mechanism and allows you to receive routes in. The same thing happens with MPLS, with layer 3 VPN, which we'll cover later on, once all the main stuff is taken care of. I'll show you guys an MPLS VPN setup. The general idea with that one is if you have two spokes coming off of the MPLS cloud and they're both running the same autonomous system, you can either use allow AS in, or the provider can use AS override on the VRFs pointing down towards the clients. So that's just another capability that's available to you. So now one of the things that I want to do now is to help reinforce these concepts is I want to go ahead and instead of jumping into next hop significance and stuff like that, I actually want to show you guys how this would work. And the idea behind this is I think the easier of the two would be to set up BGP to all of our sites into the ISPs in the middle of our topology and then advertise a couple routes. And by doing that, this way we'll get what we need advertised. And the way that we can do this is very, very simple. We'll just form EBGP peerings here, 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 and here. And then on 6 and 13, I'll do a redistribute connected, which will allow us to advertise the routes out to these guys, 3, 5, 13, 7, and that'll get those routes out there. At the same point in time, what that'll also allow us to do is any routes that are learned in that are external to our autonomous system, if we try to advertise those down to R2, 4, or 1 without having any type of IBGP full mesh or route reflection in place, we won't be able to get where we want to go. So the first thing that I'm going to do before I get into any of that is I want to get the peerings up, which shouldn't take too long, which I figured the more I do this, the more it'll make sense to you guys. So on 6, I'm going to type in do show IP interface brief, and I'm going to type in router BGP 6, and I'm going to type in neighbor 57, I'm sorry, 67, 56, 56.0.0.2, remote AS 12345. And then same thing with 67. So I'm going to do neighbor of 67.0.0.2, remote AS of 789, and that'll get me situated there. So now if I jump out here and do a show IP BGP summary, I should have a few situations here. I have the connection to 3, I'll have a connection to 6, and I'll have a connection to 7. Those are all still idle. Now what I'm going to do is on 13, I'm going to do the exact same thing. I'm going to type in router BGP 13, do show IP interface brief. I'm going to type in neighbor, and I've got neighbor 135.0.0. And 135 is 0, so it's going to be .2. Remote AS is 12345. And then a neighbor of 137.0.0.2 is remote AS of 789. Now the key factor here that I work with is the ISP is always .1 for the IP address, and the customer is always .2. So this way here is easy for me to remember. Now what I'm going to do is on 5 is I have to come over here and I have to go to the global routing table, and I have to type in interface fast 1/1 and type in no shut. Bring that peering back up, and then you'll see exactly how fast the adjacencies will come back up. It'll be relatively quick. So you'll get that up, then you'll see BGP comes up pretty quick, and then so will OSPF. And then OSPF will come up, and then we're good to go. So and then momentarily the virtual link will come up as well. So now I'm going to type in this router BGP 12345. I'm going to type in neighbor of 56.0.0.1, remote AS of 6. I'm going to type in neighbor of 135.0.0.1, remote AS of 13. Okay, that's going to get me my peerings up to those guys. Since I've already got them configured on the provider side, those adjacencies should come up relatively quickly, and we'll be good to go. Now on 13, on 7, I'm going to do the exact same thing. So on 7, we're going to do a config T. We'll type in router BGP 789, and type in neighbor of 67.0.0.1, remote AS of 6, and you can hit the up arrow and you could do 137 and go 137, go to the E. And then do 13 and hit that, and that should get our adjacencies up. And actually, do show IP interface brief. I have a feeling that the yes, this is .7. So on 6's side, I will have to go make a quick change, which will be pretty simple to do. So on 6, go to global config, type in router. Oh, it's up? Shouldn't be up. Is it? 7? Do show IP BGP summary. That's what I thought. So 6's address is do show IP interface brief. 6 is that one, but 7 is the other address. 7 is 7. So on 6, I need to go to router BGP 6, do show run pipes section BGP, find out what the address is, pull that neighbor statement out, because that's the only thing that I goofed up on. So no, and pull this guy out. And neighbor of 67.0.0.7, remote AS of 789. And there's a question, why do I have 2/24 subnets? For NAT, to test that out when we get there. And I have some other capabilities that we can work with as well. So that should get our adjacency up, and there it goes. So now we have that, so we'll go down to 7, we'll type in do show IP BGP summary, and there we have it. Now what I'm going to do on 6 is, you haven't seen it yet, but and I haven't shown you the 4-byte autonomous system either. What I'm going to do here is I'm going to type in on 6, I'm going to do the upgrade CLI. So if I do question mark and I go all the way down to the bottom here, or I type in BGP question mark, I go down to the bottom here, I have upgrade CLI. What upgrade CLI does is it allows me to upgrade to address family instance mode. And what this basically does is anything that I would want to do per address family, I'd have to go underneath the address family to do so. So I'm going to type in upgrade CLI AF mode, and I'm going to hit enter. Now what ends up happening now is it's going to say, well, you're going to be moving from the standard BGP configuration to address family specific syntax. I'm going to type in yes. Now, if I type in do show run pipe section BGP, we're going to be specific to the address family. As soon as that pulls up, now we have our peerings here, and then we just activated everything underneath the address family. Now what I need to do, in order for me to redistribute connected on 6, I need to type in address family, IPv4, type in redistribute connected. Okay. Now what that's going to allow me to do, if I was to do this from regular, from the global process, hit the up arrow, it's still going to take, actually, notice I'm hitting the tab key, nothing's happening. You can probably hear my computer dinging at me. It doesn't support that command. Even though by hitting the up arrow it took it, if I do a do show run, the syntax will be underneath the address family, because you can't do redistribute connected underneath the global process. So if you want to do anything address family specific, this is where you would do that. So that's going to be how you do that. Now if we go over to 3 and we say show Ip Bgp Summary, notice now that we are learning 6 routes. Notice that, but that's from our 36 network and from the 5 network, because we have EBGP peerings here. If we go to 5 and jump out of here and do a show Ip Bgp Summary, we're learning 6 routes, right? Now what we can do now is we can do hit the up arrow and pull the summary command off and hit the enter key, and now we have our BGP routing table. And if we look at this, as you can see, we have our peering now. Now here's the thing, and I will break this down in much more detail in the next video once we get into scaling. But right now the way that this sits is the star that you see right here indicates a valid route. The caret, or the greater than sign, this indicates a best route. So it's a valid best path. And if you look, the line that it sits on, the next hop is 56001, which means it's going to router 6. If you have a bunch of asterisks but no greater than signs, that means it cannot resolve the next hop. It doesn't know how to get there. So we'll see exactly how that would work. But this is an EBGP route. The reason I know that is because of the address. They're coming in as question marks, which means it was redistributed, which means it's 6 and 13 both, or 6 redistributed routes to redistribute connected. If we were to advertise a route via the network command, it would come in as I, or internal. So it means it was advertised internally, or as the network command. So that means I can ping, I should be able to ping, I can ping 67.0.0.7 from 5, and I can get there. If I did not have that redistribute connected, it would not work. So if I did a trace route to 67.0.0.7, I'm able to get there because of the fact that I'm going through Autonomous System 6. Now let's do the same thing on 13 though. Now, but at this time here, I'm going to go type in no BGP default IPv4 unicast. Unicast. And what that does, this command disables the automatic IPv4 address family adjacency forming, or the AFI SAFI1. So your AFI is IPv4. Your SAFI, or your sub-address family identifier, is going to be your unicast, multicast, broadcast, that type of stuff. So as we go through there's going to be specifics we have to deal with. Now we type in no BGP default IPv4 unicast. What that does means we're going to have to go to address family line, and we type in do show run pipe section BGP. By typing that command in alone, it will migrate us over to the address family configuration. Because now we have to go type in the neighbor and the autonomous system number we're trying to peer with, and then we have to go underneath the address family and actually activate it. Now again, if we want to go in here and do any configuration, we have to go underneath the address family to do so. So we're typing address family IPv4. We're typing redistribute connected. Okay, now if we go back to 5 and we do a show Ip Bgp, now we're going to have multiple paths. And the reason for that is because we're learning routes in from both router 6 and router 13. As you can see that some routes are coming in via 6. Most of them are going, so let's see, 67 should be coming in. We have some, the 137 route should be coming in via that. So we have those routes in here and they are functioning. So if we want to do a trace route, or hit the up arrow, do a trace route to 67007, we're going to go 6 to router 6 to router 7. Now you might ask, why didn't it reconverge and go over to 13? Well, they're equal cost paths, and the way that the BGP path selection works is you don't want to go in there and reconverge over to a new route. If you have a stable route in the routing table, why pull that out if you don't need to? So that's the general idea of how that would work. So at the end of the day, that's generally how this stuff would work. Now that I've covered that, what I want to do is I want to go through and I want to do an EBGP multi-hop peering. So on 3, we're going to go to global config. We're typing router BGP 12345, and we're going to type in neighbor of, we're going to say 67.0.0.7, remote AS is 789. But we have to hit the up arrow, or actually, let me go over to 7 and do the same thing on the back end. We're going to type in neighbor of, what's that, 36.0.0.2, remote AS 12345, and hit the enter key. Now you'll see that even though I can do ping 36.0.0.2, I'm sorry, what's router 3's address? That should be do show IP interface brief. It's 3, sorry. I consistently do that. And now if I ping 3, I can ping 3. But remember, EBGP peerings default to a TTL of 1. So in order for me to get the peering to come across, I have to do what? On 3, I have to hit the up arrow and go to, I have to type in what? The command sits right here. It says EBGP Multihop. It says allow EBGP neighbors not directly connected networks. So it's we're going to say EBGP Multihop question mark and then the hop count. So if you, by default, it's going to go. It's going to say 255. Now that's fine. The drawback to that though is that if we do that, then we could be 255 hops away and still form a peering. Now remember, the TTL starts at 255 and decrements numerically down to 1. Doesn't start at 1 and upgrade to 255. It counts down from the top end and works its way down to 1. So if we are 2 hops away, that means that we have to do what now? And you can't type in 2 because that's actually just 2 hop. That's decrementing 2 from 255, which will bring us down to 253. So we actually have to say the EBGP multi-hop is 253. When it says 253 hops later, we should be where we need to go, which means it'll be 2 hops away. Okay, so we have that. So now we should be okay, and the way we end up getting this to work, now that this is setting up, now, do we have our peering up? Well, not yet. What else do you think we might need to do? Need to go to the other side and do it, right? So we're going to hit router 7, we're going to type in the up arrow, and type in EBGP multi-hop, and the TTL is going to be 253. So that should form, because we're 2 hops away. So that should form our neighbor relationship. And there it goes. And then, if we look at this, and out of here, and we type in show IP BGP neighbor for 36.0.0.3. If we look at here, and we come down here a little bit, down at the bottom, well, actually, 253. Okay, so I had that wrong then. So I made a mistake. So the idea here is it says external BGP neighbor may be up to 253 hops away. So it's actually, let's tweak this, and we're going to type in router BGP 789 and hit the up arrow and go, let's go 2 hops away. Same thing with, I believe it's got to be the same on both ends. Do show run pipe section BGP. It should stay up. Just make sure the configuration is correct. Yes. So now if I type in do show IP BGP neighbor for 67.0.0.7, come down here, the neighbor may be up to 2 hops away. So okay, I had that wrong. It's actually the other way around. It's 253, and you decrement from the top end down for Ttl security. I sometimes make the mistake on that. So, and if we look, we type in and we say do show IP BGP. We are learning routes from 67. So now we have 67 in here now as well, and that's the next hop. So type in do show or do ping or do trace to 67.0.0.7. We still got to go through router 6 to get there. We just have an EBGP peering going across. So that's the general idea from that. So we can, that just gives you the idea for that. Now the next one we're going to do is from 5 to 7. We're going to go to 5 to 7, and we're going to say, we're going to type in router BGP 12345, address family IPv4. We'll type in, it's going to be neighbor. We're going to say 137.0.0.2. We're going to say Ttl Security, and we're going to say hops, and we're going to say maximum number of hops it can be away. We're going to say is 2. And that should be. Oh, sorry. Now we got a form of appearing first. Remote AS 789, and then the Ttl Security can come in. There we go. So there we have that. So now we're going to go over to 7 and do the same thing. We're going to type in neighbor of, what was that, 135.0.0.2 remote AS of 12345, and then a Ttl Security of 2. Oh, hops is 2. So do show or as soon as it comes up, we'll wait a second for it to come up. Okay, so it came up, so we'll type in do show IP BGP neighbor and 135.0.0.2. If we come down here to Ttl Security, and Ttl Security, okay, so it's the same way then. It says the external BGP neighbor may be up to 2 hops away. So it could just be that I misunderstood that, but the general idea here is to, if it's anything farther away than that, then it won't allow it to come in. And it's 2 hops away, so that's normally you would leave it kind of. It says the minimum incoming TTL is 253. So you notice how that's set up right there, right? So we could spin this around, and we could play with it to figure out exactly how many TTL it could be away. But the problem is you never know when they might add a router in between you and them. So it might be 16 today, it might be 22 tomorrow, depending on how how the providers work and stuff like that. So usually, I've never seen anybody use this in production personally, but at the end of the day, it really doesn't make much of a difference. So that's how you would do that. So that gives you an idea of how you could use Ttl Security and EBGP Multihop in order to get something accomplished. So in the next video, we will take a look at dealing with we'll deal with route reflection, and then I will show you guys how to get EBGP loop prevention in place with allow ASN and stuff like that. And right now, everything's working because of the fact we're not using the same autonomous system number. But the minute we start using the same AS number, that's when things start to change. So I hope this has been informative for you, and I just thank you for viewing.